Poisson distribution. An experiment that yields values for a random variable x, which represents the number of occurrences of a particular event, usually rare event, over a given time interval or a given region or space is called Poisson experiment. Take note of the word occurrences for this experiment. The random variable x defined in a Poisson experiment is called Poisson random variable. The probability distribution of Poisson random variable is called Poisson distribution and is denoted by this symbol. The Poisson distribution, named after French mathematician Simeon Denis Poisson, is a discrete probability distribution that expresses the probability of a given number of events occurring in a fixed interval of time or space if these events occur with a known constant mean rate. So mean is given, and independently of the time since the last event. The following are examples of Poisson random variables: the number of calls received in one day, the number of times in a month that classes in a certain city are cancelled, the number of typographical errors in one page, the number of buses that arrive at a certain terminal in 1 hour. A Poisson distribution has the following characteristics. The average of an event over a given time interval is known. So the average is given. The occurrence of a given event is independent of the occurrence of the event in another disjoint time. The probability that an event will occur more than once over a very short time interval or very small region is almost zero. That's why it is called a rare event. The probability that an event will occur once over a very short time is proportional to the length of the time interval. So if the time interval is long, then most probably the probability is high. Let mu denote the average number of occurrences per unit time or size of the region, and let small letter x be the possible value over a given time, interval, or region. The probability mass function of Poisson random variable x is defined by this equation. Where E 2.71828 is the base of the natural exponential function. The mean and variance of Poisson distribution are both equal to mu, or the mean itself. So the mean and the variance are equal. Example number 1, the average number of houses that a certain real estate agent can sell in a week is 2. What is the probability that next week the agent will be able to sell exactly 3 houses? So we have mu, or average, is equal to 2, and we need to find x is equal to 3. Using the formula of the Poisson probability, the probability we are looking for is e raised to negative 2, because 2 is the average, and then 2, the average, raised to 3, because x is 3, and then 3 factorial. 3 factorial is just equal to 3 times 2 times 1. Approximately, the probability is 0.1804. So the probability that next week the agent will be able to sell exactly 3 houses is 0.1804. Number 2, the number of lions seen by tourists on one-day safari organized by a certain travel agency is a Poisson random variable with mean equal to 5, meaning the number of lions is 5. Find the probability that tourists will see less than 4 lions on the next one-day safari organized by the agency. Solution, because we need to find the probability of having less than 4 lions. So probability of x is less than 4 is equal to probability of x is equal to 0, probability of 1, probability of 2 lions, and probability of 3 lions. In other terms, we have this one, probability of 0 lion with a mean of 5, probability of 1 with a mean of 5, probability of 2 with a mean of 5, probability of 3 with a mean of 5. Using the formula, we have this, e raised to negative 5 and then 5 raised to 0 over 0 factorial, e raised to negative 5 times 5 raised to 1, and so on and so forth, up to 3. Simplifying that, because e raised to negative 5 is common to 4 terms, we get this one, e raised to negative 5, and then we close this one, 5 raised to 0, 0 factorial, up to 5 raised to 3 over 3 factorial. Now computing for this one is 1, this is 5, this is 25 over 2, and this one is 125 over 6. We know earlier that 3 factorial is 6 because it's 3 times 2 times 1. Computing for this, you can use e in your calculator, or you can just substitute 2.72 in your e. Approximately the value is 0.2650. That's the probability that the tourist will see less than 4 lions on the next one-day safari organized by the agency.